Alrighty, everybody. Part 2 of the video. For those of you that missed Friday or would like to hear it again or slower and pause and do your own. Just like the last video, in case you're watching this one only, I am going to run through quickly. If this is your first time joining me, go find this slide on Classroom. Print it if you have access to a printer, or recreate it on your own on a piece of paper. It's a really good reference tool. We can visually organize where we're going to go with this. On the last little video for part of Friday's class, we converted moles to molecules, moles of some substance A to molecules of the same substance A. Or we could do moles of that substance A to atoms of that substance A. All of that required Avogadro's number, a definition of 1 mole equals 6.022 times 10 to the 23rd molecules of that substance or atoms of that substance. And we can make that a conversion factor that is on this toolkit on the back, written either particles over moles or moles over particles, depending on how you want to cancel out your units. The next one we're going to do today will be moles to grams or grams to moles. To do this, I have to do a sub-teach, and I'll probably stop the video at that, of how to determine molar mass of a substance. On this graphic organizer, you'll see molar mass, and it includes a hint that, hey, you need a periodic table. It's that periodic table that will help you. Speaking of, hey, you need a periodic table, I don't have one with me. Well, I do, but on the other side of the room, so I'm going to have to go grab that. But let me get this reset up. Got grams to moles, atoms. Alright, bear with me a moment. Alright, I got my pretty version. I hope you still got yours from your lab. These come in super handy. Still has all the color-coded sections. Your non-metal hydrogen. Oh, I'm not going to take the time in this video to go through all this again, but should review all the different sections on this periodic table. Make sure you know how to add those Lewis dot structures, typical ionic charges, anions and cations, and your transition metals. Anyways, I'm going to have this to the side. I'll pull it in when needed. So, molar mass. So like I said before in the last video, moles are a massive number of particles. When we have that massive number, we can start using grams. Instead of AMUs, those atomic mass units, and we're saying each atom has, nitrogen has a average atomic mass of 14.007 AMUs. Or that the isotope N14 has a mass of 14 AMUs. If we're talking about moles of nitrogen, we can actually just say that same number, but in grams. And that is part of why this is such a weird number, 6.022. It's a weird number because that is the conversion needed to start to go from individual atom AMUs to grams. This is super easy when you're talking about 1 mole of 1 atom. So let's start there. I want to know if I give a number of moles of a substance, so moles of A, what the... no. Sorry, forget this. It requires a couple steps. Just think molar mass. So, molar masses. How about the molar mass of Na, sodium? So to get the molar mass of sodium, I need to go to the periodic table, find sodium. Sodium is 22.990. So, if we have 1 mole of them, then we can actually write this as grams. So 22.9 0.499 grams of Na for every 1 mole of Na. Alright, let's do another single atom because those are a little bit more simple. How about Cl? So Cl, for its molar mass, the molar mass of chlorine, if you look at the periodic table, just a single chlorine, a single mole of chlorine, is 35.453 grams of chlorine for every 1 mole of chlorine. Alright, step up the complexity a little bit. This was a single atom, well, a mole of a single atom. That was its mass. What if we have more than one atom as a molecule, but you have a mole of those molecules? So instead of just Na or Cl, let's go Cl2. Okay. Well, a mole of just Cl was 35.453 grams of Cl. Now we have Cl2, chlorine in a pair, diatomic chlorine. So to do this, we need to look up each of the individual masses of all the atoms found in the molecule. In this case, they're both the same. So 35, go to chlorine, still 35.45 for each one. 35.453 plus, we have a second one, 35.453. Do that math, and that is 70.906, if I did that correctly, grams Cl2 for every 1 mole Cl2. Be careful that you're writing Cl2. It's not chlorine, it's Cl2, and that's why you had to do the addition. It might be helpful to think of this in multiplication as well, especially if this was like Cl8. You really wouldn't want to have to write this out or do it in your head or your calculator 8 times. So as long as they're all the same, you can do some multiplication as well. So an alternative way of solving this would have been 35.453 times 2. Again, I'm going to get you in the habit of putting parentheses around that. Obviously, it doesn't matter at all on this one, but when we start having multiple elements in the compound, you're going to want to make sure your order of operations is maintained. Make sure you don't do a 1 by 1 on a calculator that doesn't run the whole thing at the same time. So we'll still get you to the exact same answer. I'm not even going to rewrite it. It's going to get to the same answer as this. Alright, let's go that more complicated route that I was talking about, but slowly. So, what if your molecule consists of NaCl, a single sodium, and a single chlorine? Okay. So no multiplication here because we only have 1 sodium and 1 chlorine. This is going to be all addition. Just like if I was to take the mass of a quarter and a penny. I want to know the total. I'm going to have to add them up. The mass of 2 pennies is either the addition of the 2 pennies or 1 penny times 2. That's the same. But this is going to be addition only because they are 2 separate things. So to do this, we have to look up Na on the periodic table and Cl on the periodic table. And thankfully we've already done that up here. But if you wanted to again, you'd go and find sodium, you'd go and find chlorine, and you'd say, alright, well sodium is 22.99, and chlorine is added to that mass. That's going to be 35.453. do that math. And you are, I don't want to do this in my head. Sorry, I don't have a calculator handy, so I'm going to have to do this the long way to make sure I don't mess up. 35, 4, 5, 3, 2, 2.99, 3, 4, carry the 1, 4, carry the 1, 8, 5, 58.443. I think that's correct. Pardon me if I made a small mathematical error. Should be 58.443 grams of NaCl for every 1 mole of NaCl. Notice how in each and every one of these, it's 1 mole sodium, 1 mole chlorine, 1 mole Cl, 1 mole NaCl. Molar masses are defined as the mass per 1 mole. If you're ever told that you have more than 1 mole, that's part of a conversion. You'll start with that, then you'll use the molar mass. But when you write these molar mass conversion factors, it's always per 1 mole. If you look at the back of this sheet that has that stoichiometry toolkit, you'll see I've reminded you that while the number of grams of A might change, it's always 1 mole of A. The number of grams of a particular atom or molecule, always per 1 mole of that particular molecule. Let's do one last one that's just a teeny tiny bit more complicated. Try to pick one I can do nice and easily. Yeah, I like that one. Alright, how about the molar mass of, let's go oh, I'll do that one later. NH3, not 2, NH3. Let me make sure I did that right. Nitrogen can bond 3 times covalently to 3 different hydrogens. Yeah, so NH3. Alright, so what's the molar mass of NH3? Well, we need the mass of nitrogen and the mass of our 3 different hydrogens. So I'm going to do this written out as addition first, and then I'll do the math, the multiplication shortcut. So nitrogen, got to account for its mass by itself. Nitrogen on your periodic table is 14.007. I am absolutely going to round that to 14. And your hydrogens, we got 3 of them. So we need 1, 2, 3. All of these will be separated by addition. So 14 plus hydrogen's your easiest one. You can probably even memorize this one. Hydrogen way up in the upper left, 1.008. Again, I'm going to round that off to 1. 1, 1, 1. Your nitrogen is there, your hydrogen is there, this hydrogen is there, this hydrogen is there. Alright, so 14 plus 1 plus 1 plus 1. 17 grams of NH3 per, as defined, must be 1 mole of that same substance. So 1 mole NH3. Like I said, I'll show you the multiplication shortcut on that one. So instead of doing it all addition, you can do 14. Nitrogen, it's times 1, or just leave it. Plus, that accounts for our first element. Plus our second element. Hydrogen is 1, and we have 3 of them, so 1 times 3. 14 plus 1 times 3 still gets you to the same place of 17 grams NH3. Let me give you one more to practice, and I'll tell you to pause, and then try and see if you got the same answer as me. Let's do... silicone tetrahydride. So silicone H4 Si with its 4 valence electrons. Hydrogen, 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 hydrogen. 1 silicone, 4 hydrogens. Alright, pause the video for a moment. See if you can solve this. What is the molar mass of silicone tetrahydride? Silicone SiH4. Pause now. Okie dokie. Hopefully you did pause that and you tried it on your own. The solution is 1 silicone. So silicone on the periodic table. Look it up and you'll find that silicone is 28.086. So 28.086. There's only one of them. So really that's times 1 plus my second element. How many do I have there? Well, the mass of each one, hydrogen, as we saw above, is 1 gram per mole of hydrogen, but we have 4 hydrogens in this mole. So 1 times 4 of those hydrogens. So my hydrogen accounts for the 1, the subscript 4 accounts for the multiplier. Close those parentheses. Again, in this case, the order of operations would work well if it was a nice calculator, but just to be safe. 28.086 times 1 remains the same, plus 1 times 4 is 4, so 28 plus 4 becomes 32.086 grams of SiH4 per 1 mole SiH4. That is the number of grams for a single mole. When I see you guys again on Monday, we will use that molar mass to determine the number of grams if we had more than 1 mole. So 2 moles, 3 moles, 19 moles, 1,000 moles, that kind of thing. All right, but we needed that conversion factor first, and that's what we've built. We've set these all up as fractions so that we can use them as conversion factors. All right, everybody, have a good rest of your weekend.